All right. In this problem, you were asked to find um, cosine theta, tan theta, and cosecant theta, given the fact that sine theta is equal to 12 over 13. And we're working in the second quadrant, or we're working with an angle theta that is in the second quadrant. So that means we're over here. All x values are negative and all y values are positive. We can draw in a triangle right here, and we can call this our angle theta. Okay, this is our x coordinate and this is our y coordinate, and this angle right here has the degree or radians of 180 minus theta, or 2 pi minus the radian version of this theta. Okay, we're also told that the sine of theta is equal to 12 over 13. Okay, now if sine theta is equal to 12 over 13, that means we have, based on SOHCAHTOA, we have opposite over hypotenuse. So this hypotenuse right here can be labeled 13. And that means y right here is labeled 12. Okay? So since this is a right triangle, we can then solve for x using the Pythagorean theorem. So we have 12 squared plus x squared is equal to 13 squared, which means we have 144 plus x squared is equal to 169. Subtracting 144 from both sides, we get x squared is equal to, 25. That means x could equal a plus or minus 5. Since we're in the second quadrant and we're going to the left, left is negative, so x has to be the negative 5. Okay, so if sine theta is equal to 12 over 13, that means cosine theta is equal to the adjacent up here, which we have said is negative 5, over the hypotenuse. So this would be negative 5 over 13. And tangent theta, that's one of the other ones we're trying to look for, is equal to either sine over cosine, or we can come back up to this triangle and we can see that it's opposite over adjacent for TOA. So that's 12 over negative 5. So that's a negative 12 over 5, which makes sense because the slope of this is what tangent represents. And this is a negative slope when reading it from left to right. Okay, and the last one we have is cosecant theta. Now cosecant theta is 1 over sine theta. Remember, it's 1 over our normal sine cosine that starts with an S, because opposites attract, excuse me. And when we say that's 1 over sine, that means it's the reciprocal of sine. So since we know what the sine is, all we have to do is flip this over. So this is equal to, this is equal to 13 over 12. Okay, so now we have everything we need. Over here, we were to fill it in. We have negative 5 over 13. We have negative 12 over 13. And we have 13 over 12. All of these are exact answers, so we're going to leave them in that form. And that's it for quiz 2, problem number 1.